Let's talk about grading and paving now, and we're going to start with the basics of grading. You already know that the existing grade is shown in light dashed lines across the drawing, and the new grade is shown in darker lines, solid lines across the drawing. What we're going to add now is that there are also spot elevations that are shown on a grading plan, and what those are crosses on the drawing with an actual elevation number, sometimes all the way to the decimal point, so that you know exactly what the grade should be at that particular point. Also of note is that the finished grade is always over the top of whatever it's showing on the drawing. So if it's going over a parking lot, it's actually on top of the pavement. If it's going over a sidewalk, it's on top of the sidewalk. If it goes over a curb, it's on top of the curb. So it's always the finished grade, the top of. And that's going to be important as we look at how to calculate the cut and fill for grading. Calculating cut and fill in an open area on the site is actually pretty easy, because if you have the finished grade coming over an area on the site and it crosses the existing grade coming over an area on the site, we have a number to indicate those different elevations. And if you subtract the existing grade from the finished grade, you get the amount of cut and fill. If the number is negative, it means you have to take away dirt. If the number is positive, it means you have to add dirt. Taking away is cutting, adding is filling. Now, one thing that complicates this a little bit, and that is the removal of topsoil before you even begin a project. Almost any time you're working on a raw site, you're going to have topsoil across the site. And that topsoil is actually taken off the site and stored somewhere, maybe up to 6 inches. So let's say your cut happens to be a foot. Well, you've already taken 6 inches for the topsoil, so now you're only cutting 6 inches. Just something else to consider is that topsoil has to be taken off the site before you begin your grading. When it comes to the grade lines over paving, you have to consider the depth of the paving. For example, if I have a finished grade line going across paving and that value is 863, and just beneath it I have an existing grade line of 862, normally we think 863 minus 862 equals 1 foot of fill. But what if that paving, the thickness of the paving and the thickness of the gravel below the paving take up 1 foot? And all of a sudden now I have no cut and fill because I'm down that foot difference. So even though the finished grade line says 863 and the existing grade line says 862, the elevation of the soil before I start paving needs to be 862 if the pavement and gravel is a foot thick. So let's look at this in more of a 3D drawing so you can really see what's going on here. What we have illustrated here is certainly the soil on one side, then a curb and gutter, and then pavement, and then gravel below the pavement. If you look at the finished and existing grade lines on this, you can see the finished grade line goes over the pavement and the existing grade goes through the pavement. And if you were to calculate cut and fill based on this alone, what you would end up with is very little cut and lots of fill. When you take into consideration the paving, then the cut and fill changes. You're actually cutting more to make room for that curb and gutter and the beginning of the paving, and filling less because you've already got to go down so far for the thickness of the paving and that gravel. Just have to keep in mind the thickness of all your paving when you're doing cut and fill. So let's say you have to put a slab in for a building, and the finished elevation of the slab is 864. Well, let's say the slab is 4 inches thick and the gravel is 4 inches thick below the slab. That's a total of 8 inches. What height would the grade need to be before you began to put the gravel on the site and the slab? Well, it would be 864, which is the elevation of the top of the slab, minus the 8 inches. So now you're at 863 and 4 inches. There's a term that comes up often in grading, and that is the balancing of cut and fill. The goal is not to be hauling earth away from the site and not to be bringing earth into the site. that is balance, when the amount of earth that you cut from a site would equal the amount of earth you need to fill the site. If it were only that easy, you see, when you pull earth from a site, it expands, right? Because you're breaking it up. It's no longer compacted in the earth. You're breaking it up. Air infiltrates it and stuff, so it kind of expands. That's called swell. And when you put earth into a site, you've got to compact it down. So you take all this earth and you put it in, you have to compact it down. And that's called shrink. So you have to calculate how much you can compact earth to a spot, how much it'll swell from a spot, to figure out exactly how well you balance the cut and fill. This is extremely important when you're hauling soil away from the site or bringing soil into the site. Let's say you determine that you need to haul 20 yards away because you're cutting 20 yards. Well, that 20 yards that you cut will not fit into a 20-yard truck, because when you cut it, it will expand by up to 50% depending on the soil type. And therefore now you have 30 yards and it's not going to fit into a 20-yard truck. So there's a lot to consider when doing a grading estimate. Now when looking at our site, we talked about how we had a bowl-shaped site and they needed to flatten it. So they certainly cut way more than they filled. Therefore, they're hauling away lots of soil. So they try to push that soil off to the edges and then slope the edges real steeply, even putting in some retaining walls. Now let's talk a little bit about paving. And the paving comes in various forms, whether it's the sidewalks or the driveways or patio areas and so on. And whenever you have paving coming up against different materials, you have joints. And there are many different types of control joints. Now, it's not the point of this class to go into all the different control joints and how they work and what they're for. Only that you can read the plan on what control joints go where. And the way they delineated it on this plan is they use little section marks to indicate the type of control joint and how that control joint works. So when you look on the plan, you see these little arrows pointing in a certain direction with letters, A, B, C on both sides. And you reference those letters against the pavement joints shown on the plan, the details. And then you can see whether the joint needs dowel rods, bituminous fillers, and so on. You may be asked the question, what type of joint material is used at the control joint between the sidewalk on the north face of the building and the brick wall? You should be able to find that joint on the drawing and then find the detail for that pavement joint.